This is the first chemistry exam on chapters 1 through 3, free response question 2. It says a 40 milliliter sample of 0.25 molar Na2SO4. So I have Na2SO4. I have 40 milliliters and 0.25 molar. It's added to 100 milliliters of 0.95 molar PbNO32. So the key word is I see it's added. And I look, 100 milliliters, 0.95. Lead 2 sulfate precipitates. So as soon as I see precipitates, I know it's a chemical reaction, and it's lead 2 sulfate. So just as like a total note on the side, lead 2 sulfate, Pb2 plus, sulfate, SO4 2 minus, which you know because you memorized all your polyatomic ions. So that gives me PbSO4. I know I'm also going to then make, because it's double replacements, NaNO3. I know Na has a +1, NO3 as a -1. So it's not Na2NO32. It's just NaNO3. And now if I look, I realize I do have to balance, and that's why I put the 2 here. So looking at this, it wants me to figure out the concentration of lead ion in solution after the reaction. So what that means is I need to figure out how much lead I originally start with, how much lead I make that goes into PbSO4, the solid, and then I can figure out what I'm left with. So basically I know the Pb2 plus in PbSO4 plus the Pb2 plus in solution equals all the Pb2 plus in my original source of lead, PbNO32. So now I just have to find these numbers. Well, I can find how much Pb I started with. I can find out how much lead I made in my limiting reactant problem, and then I can solve for this one. So let's first find out how much lead I start with. So I have 100 milliliters of 0.95 molar. 100 milliliters is 0.1 liters times 0.95 molar. That gives me moles of lead, which in this case will be 0.095 moles of Pb2 plus start with. So that's that one. Now I got to find how much PbSO4 I make, and that's really a limiting reactant problem. But if you think about it, my PbNO32 can't possibly be my limiting reactant because it's telling me there's some extra Pb in solution. That means Na2SO4 definitely has to be my limiting reactant. And if you look, they're in a 1-to-1 ratio. So if I look at moles of this versus moles of this, the one with the smallest moles gets used up first because the coefficient of both is 1. So obviously 40 and 0.25 is going to be a lot smaller than 100 and 0.95. So I can just assume that Na2SO4 is my limiting reactant and figure out how many moles of PbSO4 I make. So 40 milliliters is 0.04 liters times 0.25 molar equals, so grab a calculator, times 0.25, I get 0.01, and this is moles of Na2SO4, and then I know when I find moles of PbSO4, that's what I want. And they're in a 1-to-1 ratio, so this also equals 0.01 moles of PbSO4. Now I know for every 1 mole of PbSO4, I also have 1 mole of Pb. So it also equals 0.01 moles of Pb2 plus in PbSO4. So that's, I'm going to draw this arrow right over here, right there. So now I have my 2 numbers. Now I can just subtract and find my number of moles. So I'm going to move this down just a little bit. And if I look and subtract, I get 0.095 minus 0.01. So 0.085 moles of Pb2 plus left. And it asked me for the concentration, so I divided that by the total liters. Well, I had 40 milliliters to 100 milliliters, so that would be 0.14 liters. And if I do 0.085 divided by 0.14, I get a concentration of 0.607 molar Pb2 plus. Now, just as a little side note, if you look at the number of significant figures in this problem, this had 3, that has 4, 2, and 2. So my answer should really have 2 sig figs. So when I'm writing my answer in my actual paper, I really should write as an answer, and I'll put it right here, something with 2 sig figs, 0.61 molar Pb2 plus would be my official answer based on sig figs.